All right, today we're starting chapter 3. We are going to identify pairs of lines and angles. So, that's our goal. Identify angle pairs formed by 3 intersecting lines. For our warm-up, name a line that does not intersect line AD. Very good. Line BC. We would write that with the line over the top of the 2 letters. If you instead called it line CB, that would also be okay. No other options there. What is the intersection of lines AD and DB? Kobe? Disagree a little bit. Akira? Disagree. Caitlin? Disagree. Ariana? Point D, thank you. 2 lines intersect at a single point. So if we were to highlight those lines, AD and DB, they only touch each other really at that one point. Okay, 2 lines will intersect at a single point. It's one of our postulates, theorems we have to remember. All right, we've got some vocab. Go ahead and fill in the words, and then we will draw pictures together in just a couple minutes. All right, parallel lines, 2 lines that do not intersect. It's also important to know that they are in the same plane. So I'll add that in same plane compared with skew below, which are not in the same plane. If you would just want to put coplanar there, that's also fine. So when we see a picture of that, it would just look like 2 lines that are never going to touch each other. However, we can't just assume that they will not touch each other. So in a diagram, you will often see these little triangles on them. If the lines each have one triangle, it means that they are parallel to each other. Okay, there's also a symbol, so if I call these lines M and N, I could say that M is parallel to N. It looks kind of like an 11 or a pause sign. 2 lines, usually they're straight up and down. Some older textbooks might have them a little slanted. That's our symbol for parallel. Skew is a little bit less exciting. Not a lot of symbols for that. Skew lines do not intersect and are not coplanar. This is a little hard to represent 2-dimensionally, so I'll do my best. Remember back in middle school, did you ever make those like boxes? Anybody? Just me? Some people did. Okay, so
hold up, you way too fast. Go back.
Here's a box. You make 2 rectangles and then you connect the corners. 2 rectangles that overlap a little bit, connect the corners. I'm just trying to make a box. We're trying to make a 3D box. Doesn't have to be fancy. So for skew lines, they don't intersect, but they're not in the same plane. So, for example, if I take this back right side here, if I take that line and extend it, I'll just do it in red. If we extend this line back here, and then we extend this one that's in the front of our box on the top. Now, in 2 dimensions, if I were to keep this line going, sure, the red lines would cross each other. But if we think about this as being a box, these 2 lines, if it's like I'm taping string to a box, those lines would not cross each other. Some people think about it like a box of tissues. If you were to take a piece of string along the front edge of the box of tissues, along one of the side back edges of the box of tissues. Those two pieces of string would never come in contact with each other. Does this make sense? Or are we not sure? Maybe, maybe not. Okay. Let's talk about it again in just a second. Let's get through parallel planes and then I'll talk a little bit more about skew. Parallel planes are just planes that don't touch each other. So generally we would have a plane represented up here and then another one down here where they're just not going to touch each other. You could think about parallel planes like the floors and ceilings of a building. If a building is built to code, generally the floor and the ceiling should not come in contact with each other. Unless you're at some architecturally artistic building, right? In this building, the ceiling and the floor are parallel planes. They don't touch each other. Does that make sense? Okay, let's pause and we'll talk a little bit more about. All right, first exercise down at the bottom. Think of each segment in the figure as part of a line. Which lines or planes in the figure appear to fit the description? First up, we want parallel to MN. So I'm just going to highlight that line, MN, and contains point J. So what line would not touch MN or would be parallel to it in the same plane but also contains point J? Good, line JL. You can call it line LJ if you would like. But really, that's going to be the only one. Any other line that goes through point J is not going to be in the same plane as MN. Okay, let's take those away. Skew to MN and contains point J. Good, JK runs up this side here. So sure, if we were to keep drawing it on a flat surface, it looks like they would cross each other. But this is a three-dimensional object, so we have to understand that they would not ever actually touch. All right, letter C pulls in one of our old vocab words, perpendicular to MN and contains point J. Caitlin, what do you think?
NJ.
Good. NJ appears to be perpendicular. Oop, not what I wanted to do. This one here appears to be perpendicular. Perpendicular means that it makes a right angle. If you called it JN instead of NJ, that's fine. Kobe? MO. ML. If it were just perpendicular, yes, but it also said contains point J. And ML would not. But yes, if it just said perpendicular, ML would have worked. All right, name the plane that contains J and appears to be parallel to plane MNO. Good, JKL. So MNO is that triangular looking plane in the back. So the one that appears parallel to it is that triangular one in the front, which is plane JKL. All right, on these you do not have a lot of writing to do. Most of it is done for you. But we are going to be reading through these and picking out examples from the picture that is shown. These angle relationships are going to be very important to us, and basically they never go away. Okay, so they'll keep popping up every now and then, in my experience, for most of the rest of the year. Okay, they can throw in these angle relationships anytime. A transversal is a line that intersects two or more coplanar lines at different points. So here, the transversal is line T. Okay, T is the one that crosses two other lines. It is possible to have a diagram where you have more than one transversal, and it depends on what lines you're focusing on. But for this simple diagram, line T is our transversal. Corresponding angles are two angles, one interior, meaning between the lines, one exterior, meaning outside of the two lines, that lie on the same side of the transversal. I don't know that that completely captures it, but it is close to capturing it. Okay, so let's, for example, take angle 1 as being our exterior angle. The angle that corresponds to it is going to be on the same side of this transversal, and it's going to be in a corresponding position. So yes, 5. Okay? So when it just says one interior, one exterior, they can't be right next to each other, basically. Okay, so 3 would not have been an option. 5 would have been our only option. Some people say they're in corresponding positions, and that doesn't really do a whole lot for explaining it. So for angles 1 and 5, they were both on the left side of the transversal, and they were both above their line that was being intersected. There are lots of other corresponding angles. For example, 3 would correspond to which angle? 8. Angle 3 and angle 8. Okay, we've got some on the other side of the transversal. 2 would correspond to what? Good. Angle 2 and angle 6. And then that would leave 4 to correspond to 7. Questions about corresponding angles? Okay, alternate interior angles are a little more clear about what they are. They lie between the two lines, so in the middle here, and on opposite sides of the transversal. So angle 3 is alternate interior to which other angle? So alternate means they're on different sides of that transversal.
7.
But they've got to be in between these two lines.
1 and 4.
So let's talk about what our options are. If we're in between the two lines, we're only looking at angles 3, 4, 5, and 6, right? So if I'm working with 3, I have to go to the other side, so that eliminates 5. But 3 and 4 are both on the same line intersection. We need one of them to be from the other intersection. So it has to be 3 and 6. Which, yes, some of you said, but I also heard a lot of other things, including angles that were on the outside. Do we all get the difference between the inside and the outside? If not, you could write it on there. This is interior. Out here would be considered exterior, and down below at the bottom is considered exterior. If you want to write that on this diagram to help you remember, that's fine with me. We do have another pair of alternate interior angles. What is it? 4 and 5. Good. Angles 4 and 5. Questions, concerns about this slide before I switch to the next one to finish this box off? Okay, then we'll go to the next one. Alternate exterior angles. So again, alternate means they're on different sides of the transversal T, but this time they have to be in the exterior parts, so not in between the lines. So one of my exterior angles is 1. Good, angles 1 and 7. Our alternate exterior, what's the other pair? 2 and 8, good. Consecutive interior angles, which are also sometimes referred to as same side interior angles. It's another name for it. Are in between the two lines, so they are on the interior part, but they are on the same side of the transversal. So 3 and 5. Good. The other pair would be 4 and 6. Okay, for now, we're just kind of talking about what these relationships are. Coming up soon, we'll learn more about what those relationships can mean given certain conditions. But for now, we'll just get familiar with identifying those relationships. Anybody needing more time on this slide? All right. Use the diagram to name the following angles. So, kind of like we were just doing, except they rearrange where the numbers are. The diagram looks a little different. So the first thing that I think we should do when we start these is identify which line is the transversal. Okay, so I'm going to give them names real quick just so that we can talk about them. If I label those lines A, B, and C, which one is the transversal? C, good. That's the one where all those angles are marked for us. That's the transversal. So when we're thinking about interior and exterior, we're looking, here's our outside, there's our outside, here's our inside. Right? And when we're looking at alternate, we're going above or below that line. So if we're talking about corresponding angles, who can give me a pair? John?
Angle 1 and angle 3.
Good. Angles 1 and 3. Corresponding is the one we have the most for. Can somebody give me a different one? Ariana. Angle 2 and angle 4. Another volunteer.
Could it be 4 and 8?
It could not be 4 and 8 because those both occur at the same intersection point. Deidreana? Thank you for raising your hand. Deidreana, yes, angles 5 and 7. Caleb? 6 and 8 would be our last pair of corresponding angles. Okay, corresponding is the one where we can use all of them in a pair. All the rest of them, we will not use all of the angles up because they will either be interior or exterior. Can't be both. Any new volunteers to give me a pair of alternate interior angles? Caitlin? Angles 2 and 7, I agree. Who else wants to give me the other one? Malik? Good, angles 3 and 6. Okay, we're done with interior, so let's do alternate exterior. Micah? Very good, angles 1 and 8. My other alternate exterior, Yanni?
Angle 4 and 5.
Good, angles 4 and 5. Questions about our alternate exterior? Okay, let's go to consecutive interior. I need some new hands. We have a lot of old hands coming back up. Maddie? 2 and 6. I will disagree with that one because they are not on the same side of that transversal. They're on different sides. Was that you, Mackenzie? Was that you? No? Oh. Oh. Bell ringing. Kara, I haven't heard from you yet. 2 and 3. I agree. Okay, so they are on the same side of that transversal. They're both above it, and they're in between the lines that were intersected. Brianna, what's my last pair?
6 and
Good. Angles 6 and 7 are also consecutive interior. Questions on example 2? Concerns, confusion, warm fuzzy feelings. All right, we've got a couple postulates. The parallel postulate says if there is a line and a point not on the line, so I'm going to draw that situation. There is a line, that's why you got some space there so that you can draw a picture. You have a line, you have a point that is not on the line, so it doesn't really matter where it is as long as it is not on the line. Then there is exactly blank line through the point and parallel to the given line. What do you think? How many lines are we going to be able to draw through this point that's parallel to this line we already have? 1. We're going to be able to make 1 line through that point. Okay, we can also draw a picture for the other situation. It again starts off with a line and a point that is not on that line. This time, there's going to be 1 line that is read the title of this postulate. That is perpendicular to the given line. So there's going to be 1 line that is perpendicular to it. Perpendicular means that it makes a right angle. Okay, so there's going to be 1 line that is perpendicular to the given line through that point. Use the diagram to answer the questions. Name a pair of parallel lines. John?
Line A, B, and C, D.
Good. Lines A, B, and C, D. How do we know for sure that those are parallel? Good, they have the triangles on them, so they're kind of small, but they are there. We can't just go based on looks. We can't go just based on, well, they don't touch yet. Okay, we've got to know for sure that they are parallel. Name a pair of perpendicular lines. Micah?
BA and AC.
Good, BA and AC. Again, we know for sure that they are perpendicular because they have the little right angle box. Is line AB perpendicular to line BC? So if we need to, we can highlight those. A, B, B, C. Are those lines perpendicular? No, why not? They do not form a right angle. No, they don't form a right angle. Questions, concerns? Okay, you should have picked up a assignment sheet when you came in, but here is the homework, just so that we've got it in the notes video for reference later.